Hello, freshmen. I'm here to take you through measurement test number 1. I'm going to go through the answers one by one. I'm going to record it, and your job is to follow along with the video, which will probably be about 15 minutes long. Pause the video, check your answers, make sure you understand everything. If not, you speak to your teacher. Okay? Let's get started. Okay, freshies. I've highlighted the numbers already, so for question number 1, we'll go through them one by one, tell you why I've highlighted those numbers and how many significant figures there are. So for example, A, 130. Right, the 1 and the 3 are numbers, they are significant. The 0 isn't, it's a trailing 0. I could rewrite this number as scientific notation and get rid of that, so therefore there are only 2 significant figures. 3009. 300.9. Alright, all 4 of these numbers are significant. The ones in the middle are sandwich zeros, they count. Okay, so we're going to say 4. Right. 766.0. Okay, the crucial thing here is there is a decimal point. That means I actually measured this 0, not that it's just there. I measured it and I actually measured 0. So this is significant. So therefore, there are 4 significant figures. Over to D, 0.0120. Right. I could rewrite this number as scientific notation and get rid of these zeros. Right. So they are placeholding zeros, they don't count. However, 1, 2, and this 0 after the decimal point, it does count because of the decimal point. So here I have 3. Alright. E is pretty much similar to A. First 2 numbers count, these 3 are just placeholders, so therefore I have 2. And finally F, I can rewrite this number as scientific notation, get rid of these, which means there is only 1 significant figure. Okay, I'm going to rewrite these numbers in standard form, otherwise known as scientific notation. So all the significant figures need to reappear again. All I'm going to do is move the decimal point. Right, and that's what scientific notation will tell me. So for example, we're going to have 1.3 times 10 to that. So what have I done to the decimal point? Well, I've moved it from here, 1, 2, that way. So times 10 to the 2. So this one, all the numbers are going to reappear again. 3, 0, 0, 9. What am I doing to the decimal point? I'm moving it 1, 2, that way. So that'll be 3.009 times 10 to the 2. This one, all the numbers appear again. 7, 6, 6, 0. They're all significant. What have I done to the decimal point? I've moved it 1, 2 that way. So 7.660 times 10 to the 2. Right, this is different. We're going the other way this time, right? But all the significant digits need to appear 1, 2, and 0. Okay, what have I done to the decimal point? I've moved it 1, 2 that way. So that's times 10 to the minus 2. Right, these numbers need to appear 6 and 8 because they are significant. What have I done to the decimal point? I've moved it 1, 2, 3 that way. So times 10 to the 3. Again, one of these numbers. That needs to appear 5 times 10 to the what? 1, 2, 3. Negative 3. Because I've moved it the other way. Easy. Okay, now we're on to question number 3. We're going to do some measurements. We're going to think about the apparatus and we're going to think about the units. So temperature of a bowl of soup, well, temperature, anything pretty much. I have a thermometer. Okay, units, well, I'd really like to see that, Kelvin, but degree C is cool as well, right? Volume of a lemon. A lemon is a strange shape to measure a volume, so we really should use displacement principle, so that would be a eureka. can, and maybe some sort of measuring cylinder. Measuring cylinder. Units, cubed, best unit I think. Volume of milk used in a banana bread recipe. Well, really, a measuring cylinder again. That writing's dreadful. Unit, cm cubed. Probably the best unit for that, or maybe milliliters would be fine. Right, time taken for an object to fall from a balcony to the ground. Measuring any time, we're going to want a stop watch. Right, units, have a wild guess. Seconds. It's the SI unit. Minutes and hours is too big. It's only going to take a few seconds. I suppose you could put milliseconds, but really, seconds is fine. Mass for USB, really, I think the digital scale is the best thing here. Units, SI unit of mass is kg, so that's a correct unit. However, it might be slightly more sensible, as a USB is quite light, to just measure in grams. Both of those are fine. Okay. Thickness of a 30cm ruler. The ruler is really thin, it's only like a millimetre or so thick, so it's pretty difficult to measure. You need something called a vernier. Vernier caliper, atrocious handwriting again. And really, units for this, the unit of measurement is actually the metre. So it could be like 0.000 meters. Centimeters is fine, millimeters is fine, but not kilometers. So meter or smaller is fine, okay? Okay, moving on to question number 4. So we've got a student who's going to use a ruler to measure a height of a pile of wooden blocks, riveting stuff. The reading was inaccurate because the student's practical technique was poor. Right, so why? Let's have a little look here. Well, first things first, why is my ruler here? The ruler, the zero of the ruler should be down here somewhere, because it should be the start of the thing you're measuring, the blocks. Why is the eye looking at an angle like that? That is also nonsense. The eye should be down here somewhere. Okay, this student is a donut and is going to get a very bad measurement. Very inaccurate measurement. So what we do? Figure 1-2, show the correct method to read height h using the 30cm rulers. Well, you know what? The ruler should probably move down a bit. Ooh, not very good drawing of a ruler. And we'll have, oops. Right, and we'll have 0 in the ruler being at 0 next to the pile of blocks. That would be useful. We'll have the eye. It's a strange looking eye. We'll have the eye level with the blocks. That is a sensible way to measure this height. Either of the suggestions will get you 1 mark. Thank you. What else do we need to do? Alright. Use your ruler to measure the height. Marked H. Oh, okay, so actually, you have to measure it. So you actually have to measure the height. If you measure the height with a ruler, you should have found it to be 14 mm or maybe 1.4 cm. A mark for nothing, for measuring a height with a ruler. Okay. Figure 1-2 is drawn to scale. It's 1/10 of the actual size. Calculate the actual thickness of one block of wood. Okay, so the whole pile of blocks is 1.4 cm. How many blocks are there? 1, 2, 3, 4, 5, 6. Alright, so one block is 1.4 divided by 6. which equals, I'm going to use the mathematical calculator in my head because I'm such a genius, 0.2333. So yeah. Okay, but then we've said it's drawn to scale and it's a tenth of the actual size, so we need to multiply this all by 10 to get the real size. So if we did it all by 10, okay, 0.2333 times 10. Oh, I can do this. I can totally do this math. It's 2.333. Oh, wait a minute. What should I do here? Okay, that's what we think. Let's think about significant figures. I only had 2 significant figures in this piece of data. 2 here. So my answer should only have probably 2 significant figures. So my answer should only be 0.3. See, no. I didn't actually measure these. I don't know these. That's just math. Alright. Job done. 2 marks. Okay, on to question number 6. In an experiment to determine the volume of glass beads, a student used the displacement method to determine the volume of a glass bead, blah 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 blah, as shown in the diagrams below. Right, here's where it gets a bit nippy. What is our readings? Well, this one looks pretty straightforward. That's 80 cm cubed. This one though is a pain. Right. What's the scale? So we've got 1, 2, 3, 4 divisions, 5, and we've got to cover 20. So it's going to be, each of these lines is going to stand for 4. So that's 4, 8, 12, 16, which means this is 96, is that right? Yeah. 96 cm cubed. What do I do? Oh, write in these values. Okay, job done. 80 cm cubed. Boom. 96 cm cubed. Please don't write a big waffling sentence here. Nobody can bother reading it. Just write the values down. Right. Calculate the volume of 275 beads. Oh, subtraction. So before we had 80, we put the beads in with 96. What's the volume of the beads? 96 minus 80 equals, oh, I can do this, yes, I am so good at math. Woohoo. Calculate the volume of 1 glass bead, oh, right, so we had 16, how many beads did we have? 275, so 16 divided by 275 is 0.058. I'm going to go to 2 sig figs because I had 2 sig figs here, right? 0.058. What's my unit? cm cubed. Job done. Excellent. Okie dokie, question number 5. We're rolling through it here. An unopened bottle of olive oil, exciting, has a mass of 0.88 kilograms. Ooh, it's got a big bottle. Empty bottle has a mass of 0.34. Calculate the mass of the olive oil. Alright, full is that. Empty, the bottle weighs that. What's the olive oil weigh? 0.88. Take away the mass of the empty bottle. 0.34. And that's going to equal, blah, 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 math in my head. I'm so amazingly good. Blah, blah, blah. Oh, look, 0.54 kg. Hooray! 1 mark. Okay, so the olive oil weighs that. What have we got next? The olive oil is poured into 3 measuring cylinders. Okay, 3 250 milliliter cylinders. Jolly good. The first 2 cylinders are full to the 250 mark. The third is shown in the diagram below. Okay, what's going on here? What's the volume of olive oil in the third measuring cylinder? So it's going to about here somewhere. Well, that's 50. There are 1, 2, 3, 4 divisions, which means that must be 40, 30, 20, 10, 0. So this is roughly halfway between 10 and 20. I can't really tell anything more than that. It's not that precise. So I'm going to put down 15. What's my unit? cm cubed. Easy peasy. Calculate the volume of olive oil in the unopened bottle. Okay, so we had 2 times 250, which is 500, because remember it said they were first two cylinders are filled to 250 mark, and had that wee extra bit left over, plus 15. So the total is 3, another mark. I'm good at this. Right. Okay, part D. Density equals mass divided by volume. Right, what's my mass again? I've forgotten now. 0 point something or other, blah 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 0.54, right? Blah 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 blah. Ooh, 0.54 kilograms. Right. Mass is that. What's my volume? It's just up there. 5, 1. Oops, no. 5, 1, 5 cm cubed. Calculate the density of olive oil. Express your answer to 2 sig figs, alright? So density equals mass, that's 0.54, divided by volume, which is 515, so that equals, oh, this is disgusting, this is a horrible number, right? 0.00104, okay, that's absolute nonsense. There is no way we measured anything to that level of precision, right? No chance. What level of precision did we measure to? We had, how many sig figs? We had 2 sig figs here, 3 sig figs there. So our answer should have the same as our least precise number. So our answer should have 2 sig figs. So 0.001. Okay, I have to round here, 4, but that unfortunately that rounds down, so 0 units. kg per cm cubed. See what I've done there? Let them move it. Oh, there we go. A person winds some thread tightly 3 times around the length of a meter ruler and cuts the end off level with the left hand. What is going on here? Right, this is quite confusing. Alright, it's a 1 meter ruler. I'm going to take a piece of thread and wind it that way. So how long is that? A meter around the ruler, back, and that's 2 meters. So that's 1 wind. How many times am I going to wind it round? Oh, 3 times, so that's 1. Oh, don't do that to me, no. What's 1 wind? We'll do it again, 2, and again, 3. So the length is going to be 2 times 3, which equals 6 meters. I will admit it's a tad confusing, because if you look at the picture, it looks like there are 1, 2, 3, 4, is there something? I don't know. But if you read the question, it says 3 times. So the answer is 6. Is the actual length of the thread slightly greater or slightly less than your answer? Well, it's greater. Why? Well, when I was winding it round, it's got to go around like the edge of the ruler, so it'll be a little bit more, because it's going to go to the end, around, back, back. So there'll be reason it has to go round edge of the ruler. Job done. Tick, tick, 2 marks. Hooray! Right, next question. An integrated science class was asked to investigate the factors affecting the heart rate. Is that right? Heart rate? Okay, so we're looking at factors affecting heart rate. One student decided to investigate the effect of different types of exercise. Okay, different types. Right. For each test, the student exercised and immediately took the heart rate and recorded it in a table. What's the dependent variable? Okay, what is the thing that we are changing? We're changing the types of exercise. So, types of exercise, right? What's the thing we're measuring? We're measuring heart rate. So that is heart rate. Please do not write sentences, just write the variables. Right, list 3 possible variables that the student should keep constant throughout the experiment. Okay, what could affect the heart rate? Well, I suppose how long it was. So how long the exercise was. So if you like exercise for half an hour rather than 10 minutes, so I suppose that's time of exercise. Depends how you take the pulse, how long between taking the pulse. We'll just put method of pulse taking. You should always take it the same time after you stop, in the same way. What else could affect it? Well, I know that if I'm really, really hot, my heart rate goes a bit better, I get tired more quickly, so I think the sort of surrounding environment. Surrounding environment. Is that how you spell environment? Alright, so for example, if I'm playing football out in the field on a hot day, I get really tired really quickly, right? So that's like temperature of stuff of outside. Anything like that. You know, anything sensible that's we can't say the same stock of the same thing. It's a variable. What could affect the experiment? Alright, and that's it. Job done. Apologies for the handwriting and being Scottish, but I think you get the point. Alright, I'm not very good at handwriting, but I'm very good at graphs, alright, and mathematics. Okay, bye freshmen.